Here we are learning about the mass density formula of a one-dimensional object. Consider a rod as shown, oriented along the x-axis, so that the left end of the rod is at x equals a, and the right end of the rod is at x equals b. Note that although the figure appears three-dimensional with some thickness, for mathematical purposes, we assume that the rod is a one-dimensional object. Now, if the rod has a constant density ρ, then we can easily find the mass by multiplying the density by the difference of A and B. However, if the density is not constant, the problem becomes a little more challenging. When the density varies from point to point, we use the linear density function, ρ of x. So, we have a linear density function, ρ of x, of a rod oriented along the x-axis on an interval from A to B. So the mass of the rod can be found by integrating ρ of x with respect to x from A to B. Let's look at finding the mass of a rod oriented on the x-axis given its density. If we are given a density function of a rod ρ of x that is oriented on the x-axis over a given interval from A to B, then the mass of the rod is found by evaluating the integral of ρ of x dx from A to B. Since we are given a density function, let's substitute this function as well as the endpoints of the interval into the formula. Now, notice that the integrand is a composition of functions. So let's let u equal x plus 1. Differentiating, we get du equals dx. Now let's find our new limits of integration. Substituting 0 for x and u, we get 0 plus 1, which is equal to 1. Substituting 8 for x, we get 8 plus 1, which is 9. Substituting u and du, and using our new limits of integration, we get the integral of u to the 1/2 du from 1 to 9. Integrating, we get 2u to the 3/2 over 3, evaluated from 1 to 9. Now we can substitute the limits, and we get 2 times 9 to the 3/2 over 3. Minus 2 times 1 to the 3/2 over 3. Simplifying, we get 52 over 3. Therefore, the mass of the object is equal to 52 over 3.